Today we'll be looking at the graphs of absolute value equations, and hopefully from last chapter you remember that they are V-shaped. So again, an absolute value equation is a V-shaped graph that points either upward or downward. So it could look like one of the following: a V shape going upward or a V shape facing downward. The translation then, a translation, if you think of it that we've done before, is just a slide. So it is a shift horizontally, vertically, or you could do both. The result is a graph of the same shape and size. Its only difference is its location. So example number 1 is what happens if you have a vertical translation. So below are the graphs. This is the graph of y equals the absolute value of x. So this is the basic one that you need to understand. So if you look here, the vertex is at 0, 0. And then you go up 1 over 1 to get to the next point on each side. So the next points there are up 1 over 1. Describe, and here, this one is y equals x plus 2. So if you look here, here's my vertex on this one. Up 1 over 1, up 1 over 1, the points are still there. So it's the same shape and size because I go up 1 over 1 each time to get to the next point. But what happened? How are they different? Okay, well, first of all, it asked for how are they the same. They are the same because they have the same shape and size, and I checked that by making sure they went up 1 over 1 to the next point. So that means both sides have the same slope. How are they different though? The difference is their y-intercept. This one has a y-intercept of 0. This one has a y-intercept of 2. So the difference there is their y-intercept, or it moved up 2. Okay, example number 2 then is graphing a vertical translation. So it says graph y equals x minus the absolute value of x minus 1. Start with the graph of y equals the absolute value of x. Translate every point what? Well, if I recall up here, this plus 2 on the outside meant I moved up 2. So this negative one down here then means I'm going to move down. So if I look here, I'm going to move down 1 unit. It says start with the graph of y equals absolute value of x. So my vertex, that's the basic one, 0, 0. I go up 1 over 1, up 1 over 1. And the same thing over here, up 1 over 1, up 1 over 1. And then I need to use my straight edge to complete that graph. Put my arrows on the ends, and that's my basic graph. Okay, so my next one then, it said all we're simply going to do, because the negative 1 is on the outside here of the absolute value, is just move everything down 1. So I'm going to move this point down 1. This point, oops, I moved down 2, so I got to be careful, down 1. This point, down 1. Over here, down 1, down 1. And then you can go ahead and connect them with the straight edge as well. So same shape, same size, all we did was simply move it down 1. And there's your graph. Go ahead and turn the page for our next examples. Write an absolute value equation. Moving down, we went minus 8. So my absolute value equation, the basic one, is y equals the absolute value of x. If it's down 8, I put minus 8, and you have to make sure that you put on the outside of the absolute value sign. That's a big difference. This one is up 6, so I go plus 6. So y equals the absolute value of x again. This time I'm going up 6, so I put plus 6. So those are my two equations if it's going to be moving the basic one either up or down. So those are vertical translation. The next one we're looking at is the horizontal translation. So use a graphing calculator and calculate both of the following equations. And that should say graph both of the following equations, sorry. There's nothing to calculate there, we just want to graph it. So if you do not have one, You'll need to try this when you get to class. So when I graph it, it asks what happens to the graph. Well, simply, if I look at it, same shape and same size, but it moves 3 to the right. Okay, and if you're not sure how to graph an absolute value one, you need to do the following. And let me type it in here so you can write it down. Again, when we graph, we go to the y equals button. So you're going to do that. Second thing is you're going to hit the math button. Then you're going to arrow over to NUM. And you're going to hit enter. And it's the AB. Not sure why it's not typing. Okay, it's not going to type anymore, so I'll just have to write the rest in. The ABS, and it shows on the y equals screen. Okay, and then you go ahead and you close the parentheses. So if you look at that, we're going to go to the y equals button, and we're going to hit the math button, which is underneath the green alpha button. You arrow down to where it says arrow over to number. ABS is 1, so that's why you just hit enter. And it shows up as ABS parentheses. Whatever in the parentheses is inside the absolute value sign. So in the first one, I'm going to enter X, and then I'm going to close my parentheses. The bottom one, I'm going to do the same math, go over to number. I hit enter for ABS. This one I enter in X minus 3, close my parentheses, and now I can graph it. And now that I'm looking at it, it moved it 3 to the right. What do you think would happen to the following graph? So up here, this -3 inside the absolute value moved it 3 to the right. This time I have a +4 inside the absolute value symbol. So if I go ahead and I graph that, again I'm going to go to the y equals. I would clear out my equations. To get to the absolute value, just as a quick review, you're going to hit math, scroll over to number, enter because ABS is number 1, and I'm going to enter in X plus 4. Close my parentheses and graph. So if I look there, it moved 4 to the left, and hopefully you could have guessed that using deductive reasoning skills. So now it wants us, it has us some examples down here, and it says graph each of the following by translating the basic one. Okay, and by translating the basic one, it just means that you know that you go up 1 over 1 to get the angle of the sides. So if I look here, this is saying +2 inside the absolute value, so I'm going to move left 2. So it starts at 0, 0 normally, so I'm going to the left 2, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, and same to get the angle on the other one, up 1 over 1, so we have the correct slope on those sides. And then I'm just going to go ahead and connect them again with a straight edge. You need to make sure you're using a straight edge. That's why at the beginning of the chapter, I suggested you have a straight edge that you keep in your binder. And this one doesn't want to cooperate with us. Okay, so you got the idea there. It should have been over 2. Let me try that again. I'll start with the other side this time and see if it'll let me work. I'm still cutting it off there, so you get the idea there. This would be the correct part of it. I'm not sure why only part of it's working. And there you go. This one is a -2, so inside the absolute value.
Allen, please report to the main office. Emily Allen, please report to the main office.
It means you're going to move 2 to the right. So originally I start at 0, 0. I'm going to move 2 to the right. Up 1 over 1, up 1 over 1, same thing here, and then we connect those with our lines as well. So basically what you need to remember is the original one always starts at 0, 0, and it goes up 1 over 1 for the slope of the sides, and then you need to remember if it's in the inside of the absolute value or not on the inside of the absolute value and how that affects it. Example number 5 is writing an absolute value equation. So if I look here, if I'm moving to the left, I know I'm going to be on the inside, and it's going to be a +8, which is kind of backwards thinking, so you got to be careful there. X plus 8. Make sure it's inside the absolute value symbols, otherwise you are incorrect. 6 units to the right inside the absolute value, minus 6. So I get y equals absolute value sign x minus 6. And there's your two equations. Go ahead and complete the quick checks for this section and then look at your schedule to figure out the assignment that goes with it.